The graph of cosine is very similar to the graph of sine. Again, the input x corresponds to an arc length along the unit circle. This time the output is the x value from the location on the circle. Here's where the variables involved can definitely lead to confusion. The two x's I just mentioned aren't the same x, of course. The orange x, measuring arc length, will get graphed on the x-axis of the cosine graph. The green segment, representing the x values from the circle, becomes the y value of our cosine graph. Let's look at some points on our graph. If we start at 0 arc length on the unit circle, the x value on the circle is 1. So the y value on our graph will be 1. As we proceed around the circle through quadrant 1, the x values of our locations decrease to 0. Continuing through quadrant 2, the x values of the circle turn negative and decrease to -1. In quadrant 3, the x values of the circle head back toward 0. And finally, in quadrant 4, they increase back up to 1. The visual connection might be easier to see if we momentarily rotate the unit circle so that we can view the circle's x values vertically. Now hopefully you can see how the cosine wave takes shape. Just as with sine, the cosine graph has period 2 pi, amplitude 1, and continues indefinitely on both left and right. If we plot both sine and cosine together, you can see that they are the same shape, just shifted horizontally from each other.